Good morning. Happy Monday. I hope you had a great weekend. Here's what I'd like you to do. Do you have something good that you'd like to share with me or just anything at all? Send me an email and let me know what good things going on. Or if you just want to send an email and say hi, I would sure appreciate it. So I hope you guys are doing well. We are doing 5.6 today. Okay, so let me let my other computer in. We are all set to go. Okay. Here we go. And share my screen. All right. Here we go. 5.6. Write an equation that has a rate of change greater than the rate of change of the line below. Okay, so first we need to know what is the slope of this line, and then we can come up with any equation in slope-intercept form with a bigger slope than what's shown, okay? And what that means is it's just going to be steeper, okay? So what we're going to do, I'm going to enlarge this, and we just need to figure out, M is rise over run. We can look at this and we know that it is positive because it's going uphill. So puff, puff, positive. And we're simply going to count. Okay, so we're going to start here. 1, 2, 3, 4. So our rise is 4 over 1, 2, 3 over 3. Okay, so we have our slope of this line is 4/3. We just need something that's bigger. Okay, so this one, if we were to make that a decimal, 4 divided by 3 is 1.33333. So what if we had a slope of 2? That is steeper than 4/3. Okay, so it's a steeper line. So let's do this. We're going to say y equals, and we're going to have a slope bigger than 4/3, 2x, and then it doesn't matter what our b is. Okay, so let's say plus 3. All right, so this is the equation of a line that has a rate of change greater than 4/3. Okay, and that's how we'll show it. Move on to number 2. Number 2 says, consider the equation 3 times 2x minus 3 equals ax plus b. Find a value of a, and a value of b so that the equation has infinite solutions. So we need them to be equal on both sides of the equal sign. And what it means is it lays on the same line. They're the same line. Okay, so here we are, we're on number 2. We're going to say 3 times 2x minus 3 equals ax plus b. Okay, so add the opposite in here. And now we're going to distribute 3 times 2x and 3 times negative 3. So that gives us 6x plus negative 9, since a positive times a negative is a negative, equals ax plus b. So in looking at this, here's my a and here is my b. So we want a to be 6 and b to be negative 3. And that's going to give us infinite solutions. Okay. Put that down there or it would bug me. All right, number 3. Write the equation of the line represented by the XY table. Okay, so to write an equation of a line, we know that slope-intercept is y equals mx plus b. So what we need to do is we need to find m and we need to find b. Easiest thing to do is to find our b when x is 0. That is where our y-intercept is. That means y is b. So we already have b equals 4. Okay, so now for our m is our change in y over our change in x. So if we were to look at what we're given right here, we can go y minus y, which is 4 over x minus x. Okay, that's going to be negative 1 minus 1 or plus another negative 1. Okay, so that's going to be, let's see, 6 minus 2 over negative 1 minus 1 at the opposite. That's going to give us negative 2. 4 divided by negative 2 is negative 2. Okay, so we have an m of negative 2. So our equation is y equals negative 2x plus 4. Okay, good. All right, so that brings us to our math work. Let's see if I can enlarge it because it's kind of small here. So this says, write the equation of the line that passes through the given points. So on Friday, you were given the slope and 1 point. Now we're giving 2 points. What we need to do is find the slope between those 2 points and then find our b, okay? So for number 1, yes, you have to write it down. We're given negative 1, 1 and 1, 5. First thing that we're doing is we're finding the slope. Okay, so we're going to say this is number 1. Our slope is the change in y over the change in x. And that's what x2 minus x1 over y2 minus y1 over x2 minus x1 is. It's the change in y over the change in x. Okay, so we're going to go y minus y over x minus x. Okay, so 5 minus negative 1 over 1 minus negative 1. 2 negatives means we add the opposite, gives us 6 over 2, which of course is 3. Okay, so let's put it into slope-intercept form. Now we have y equals mx plus b. So we know what our m is. And we're going to plug in one of our xy coordinates because what we don't know is b. Okay, so for this one, they used this one here, 1, 5. So 5 is our y, 1 is x plus b. And then now we just simply solve for b. So 5 equals 3 plus b. I'm going to add the opposite to both sides. Gives us 2 equals b. So for number 1, our equation is going to be y equals 3x plus b. All right, so it's the same thing that we did on Friday, but now what we're doing is we're solving for b. Oh, I'm sorry. I totally messed that one up. Solving for b, and then you have to put in the b. Ah, there we go. Woo! Does it match? Yes, it does. All right, number 1, there we go. All right, let's go on to number 2. So I can leave my y equals mx plus b. Erase some of this up here. Okay, so now we have number 2. Okay, we're here. We have the coordinates of 2, 4, and 3, 6. So we need to find our slope. Okay, so first we find our m equals, and we're going to say y minus y over x minus x, or change in y over change in x. And that's going to be 6 minus 4 over 3 minus 2. gives us 2 over 1, which of course is 2. Okay, so then we can pick either one of our points, either 2, 4, or 3, 6. And I'm just going to pick the first one, this one here. So I'm going to say, okay, so 4 is my y. Y equals, here's my m right here, 2 times my x plus b. Okay, so now the only variable is b, or my y-intercept. 4 equals 4 plus b. Add the opposite, which means that 0 equals b. So for number 2, my equation is y equals 2x. And you can put plus 0 if you'd like, or just y equals 2x. Okay. All right, get that one all erased. Brings us to number 3. Okay, so here is our number 3 right here. And first thing we need to do is find our slope. Make it a little bit bigger here. So change in y over change in x. And so we're going to go 7 minus 3 over 2 minus negative 2. Okay, so 7 minus 3. Of course, we're going to add the opposite. Add the opposite. Gives us 4 over 2 plus 2 is 4. So we have a slope of 1. Now we're going to use one of our points. Oops. So I'm going to use my positive numbers. I like those better. I'm going to use 2, 7. So when I have my y equals mx plus b, I'll use my 7 as my y. My slope is 1 times x plus b. Add the opposite. Gives me 5 equals b. Okay, so plug that into my slope-intercept form right here. I'm going to have y equals x plus b. Okay, so in that's my slope of 1. So it could be 1x plus b, but we know that if it's just an x, that the 1 is the coefficient. There is number 3. Okay, on to number 4. So if you understand what you're doing at this point, if you'd like to either put me on mute or pause the video, get the rest going, and then check your answers, that would be awesome. If you want to keep working with me, that's fine as well. Number 4. Okay, we're right here. Okay, so the next thing that we want to do is we're going to find our slope. Okay, so we're going to go y minus y, which is 2 minus 1 over x minus x, 8 minus 4, gives us 1 over 4 as our slope. Oops. Mx plus b. Okay, so now we're going to use one of our coordinates. Use this one here, 4 and 1. So 1 is y equals 1/4 times my x is 4 plus b. This cancels out, gives me 1 equals 1 plus b. Of course, this is 4 over 1. Add the opposite. gives me 0 for my b again. So now I'm going to have y equals 1/4 x. So you can either leave that as 1/4 x, or if it helps you to know your y-intercept is 0, you can put that in there. All right, on to number 5. Okay. Number 5. Okay, so for number 5, first thing we need to do is find our slope. Reminder, m equals change in y over change in x. So here we go. Gives us 3 minus 5 over -3 minus -9. When we add the opposite, then we're going to have 3 plus -5 gives us -2 over -3 plus 9 gives us 6. When we simplify that, that gives us -1/3 for our slope. So we have y equals 1/3 x plus b. We need to know what b is, so we're going to plug in one of our coordinates. I'll use -3, 3. So 3 equals 1/3 times -3 plus b. Of course, that's over 1. Simplify. Gives us 3 equals, oh, I forgot my x in there, -1x. Oh, I'm sorry, I do have my x. I don't know what I was thinking there. Sorry. All right, so -1 plus b, add the opposite to both sides, gives us 4 equals b. Now we can write our slope-intercept form, which is y equals 1/3 x plus 4. That is number 5. All right, just a couple more. Number 6. That erased. Okay, number 6. Here we are. So our slope change in y is -1 minus 2 over -2 minus 1. Add the opposite. Let's see. Ooh. Okay, so it gives us a -3 over -3. -3 divided by -3 is a +1. So we have y equals 1x plus b. Plug in one of our coordinates. I'm going to do the +1, which is 1, 2. Oops, this one here. There we go. So 2 is y equals 1 times 1 plus b. Add the opposite to both sides. Gives us 1 equals b. So our equation is y equals x plus 1. That's with a slope of 1. Okay. On to our last problem like this, number 7. Okay, where are we? Number 7. First thing we need to do is get our slope, change in y over change in x. Okay, so we're going to say slope equals -2 minus 2 over 5 minus -5. Add the opposite, gives us -4 over 10. When we simplify that, that gives us -2 over 5 for our slope. So y equals -2/5 x plus b. Now we're going to plug in one of our xy coordinates. Doesn't matter which one, I'll use the first one. So I'm going to say 2 equals -2/5 times -5 plus b. Of course, that's -5 over 1. So these cancel out. 2 equals a negative times a negative is a positive. So that gives me a +2 plus b. Can't believe it happens again. Gives us a b of 0. Okay, so I have to write it over here. Y equals -2/5 x. And then at this point, you can either leave it like that or add +0. All right, and that's number 7. All right, now going on to number 8. This is not the first time we've done it, but it's been a while since we've done a dilation. So we talked about dilation. It's like if you go to the doctor and the eye doctor, and they put the drops in your eyes and it makes your pupils dilate or get bigger. That's what we're doing. So it says dilate triangle ABC by a factor of 3 with respect to the origin. And it always says with respect to the origin, and the origin, of course, is 0, 0. Okay, so first thing we're going to do is find out what are the coordinates of point A, point B, and point C. And then we're going to multiply those by 3. Okay, so we have A. This is our pre-image. It's 1, 4. Okay. And so we're going to dilate that by 3. So we are going to do, I don't know if I really gave myself enough room here. So we're going to do 1 times 3 and 4 times 3. And that's going to give us our image. So A1 of 3, 12. Okay. Easy peasy, right? Okay, so now, which of course it does not give me room to do that on my graph. So let's see here, 3, we're gonna have to, so 3, 8, 9, 10, 11, 12. So there's A1. Let's see if I can make it big enough. Ooh, it's like a blob. A1, that's all right. Okay, so now we have our B. So our pre-image B is 3, 1. We're going to dilate it by 3. So 3 times 3 and 1 times 3, which gives us an image B1 of 9, 3. So let's see here, 6, 7, 8, 9, 3. I don't know if that's really 6, 7, 8, 9, maybe a little bit more, 6, 7, 8. Somewhere right in here. Oops, I need to put my pen back on. 6, 7, 8. Now I lost my spot. And maybe right in here. B1. Looks like scribbles on there. I'm sorry. Hopefully you're understanding what I'm doing. Let's see, maybe if I just scooch this one out of the way. There we go. B equals equals. Okay, so now we have C. Our pre-image of C is at 1, 1. We're going to dilate it by 3. So multiply each point by 3. Easy. Which gives us a C1 of 3, 3. And that one is on my graph here, right there, C1. Okay, so let's see if I can draw some straight lines. Okay, so this is going to give us our image here. Okay, so there's our new image. Do you see that it's bigger than the pre-image? And times are dilating time with respect to the origin of 0, 0, which is here. Let's see if I can, I'm going to use purple. So if you were to have a straight edge, which it just never works with my touch screen here, but if I were to go from the origin, not too bad. With respect to the origin, it should kind of go out as you see the dilation get bigger. So I don't know if it's easy to see or not on this video. It's very tough for me to show you. This is how you graph it. Over here, this is how you do the calculation. All right. Hopefully it makes some sense for you. Chapter 6 actually does translations, reflections, dilations, and scatter plots. So hopefully you'll understand it more next chapter. This is just really a preview. All right. So log out there. I hope you guys are doing well. I hope today kicks off a fabulous week. I do miss you. I wish I were in class with you. Work hard, and as you go through your week, remember who you are, remember what you stand for, and lead by example. Miss you guys. See you soon. Bye-bye.